All right, so this is section 8.3, day 1, which we discussed the dot product and also finding an angle between two vectors. So first off, let's talk about the dot product. When you see v dot w, where v is a vector and w is a vector, let's say v is a vector a1i plus b1j and w is a2i plus b2j, then to find the dot product, what you're going to do is you're going to see v dot w equals, well then you put equals. In order to get it, what you're going to do is you're going to take the a components and multiply them, the b components and multiply them, and then add those two together. So you're going to take whatever a1 is, multiply that by a2, so you'll multiply these two. Add that to the b components multiplied, b1 times b2. So remember, all of these are numbers. So is the dot product a vector? No, it's a number. In fact, it's a real number, which can also be called a scalar. Okay, so let's do an example of these two right here. So given vector v is 3i plus 4j and vector w is negative 5i plus 2j, find v dot w. So v dot w is equal to, you're going to multiply the a values, so that's 3 times negative 5, and I'm putting the negative 5 in another set of parentheses so it doesn't look minus, plus 4 times 2, like so. Now you just find that product addition, you have to multiply and add. So 3 times negative 5 is negative 15, plus 4 times 2 is 8, and you get the dot product is negative 7. So v dot w is negative 7. So notice it's a real number. All right, w dot v. So I have w dot v is, multiply the a values, negative 5 times 3, plus multiply the b values, 2 times 4. We get negative 15 plus 8, which is negative 7. So notice you get the exact same answer. So the reason why we did that, if you're like, you just did the same problem twice, it's to show that v dot w is the same thing as w dot v. You get the same thing. All right, next it says find v dot v. So we're going to take the vector v and multiply, and find the dot product of that. So v dot v, you're going to take the a values and multiply them, which that's 3 and 3, plus the b values multiplied, that's 4 and 4. So we get 9 plus 16. So v dot v is 25. All right, now it says find the magnitude of v. So remember, our magnitude formula is to do the square root of a squared plus b squared. So a was 3 squared plus b was 4. So I get the square root of 9 plus 16, which is the square root of 25, which is 5. So the length, or the magnitude, is 5. What are we supposed to learn from doing that? Notice the 25s right here. So what you're supposed to notice is that the dot product of v, so v dot v, is the same thing as the magnitude squared. Okay, so 5 squared is the same thing as 25. And it's because the magnitude would be square root here. And if you notice, this is 3 squared, this is 3 squared, this is 4 squared, this is 4 squared, this is addition, this is addition. So you're going to get the number 25, but on the magnitude, you square root it. And on the dot product, you don't. Okay, more properties. The distributive property works. So if you saw u dot, and then 2 vectors being added, v plus w, you can do u times v dot, I did the product wrong there. I got to distribute that. So I'm distributing. So you can do u, that's a u, dot v plus u dot w. Right? It's a u again. So you can take the dot product, you can either add the 2 vectors, v and w, and then take the dot product of u and that new vector, or you can do the dot product of u and v and add the dot product of u and w. All right, and then the next one, the dot product of v, a new vector, and 0 is 0. All right, last thing that we're going to talk about today, and it uses the dot product, that's why the dot product was first, is the angle between two vectors. So it says if u and v are two non-zero vectors, the angle theta, which as long as theta is in between 0 and 180, between u and v is determined by the following formula. So first let's picture what this looks like. So let's draw an x and a y axis here. So let's say you had one vector that was in the first quadrant that looked like this, and it ended right here, let's say. And then you had another vector in the second quadrant that looks like this and ended here, let's say. And you wanted to find this angle right here, which is theta, okay? So this is vector u, and this is vector v, let's say. And it doesn't matter which one's what. Oh, we did just v and w, my bad. V and w. Let's say this is vector v, and this is vector w. And it doesn't matter which one's which, okay? All right, so what you would do to find that is that you would, and I can use any letter, so I don't know why I erased u and v. You can use u and v. You can use v and w. It doesn't matter. Oh, it says u and v. My bad. Look at me go crazy. Okay, so let's make, let's make, hard time. Let's make this a u, and that's like a v. Okay, so if u and v are two non-zero vectors, and you want to find the angle in between them, so my picture's right. Here's the formula that you would use. You would do cosine of theta is equal to, you would find the dot product of u dot b, and then you would divide that by the magnitude of u, so u again, times the magnitude of v. Okay. All right, so let's go ahead, and this is actually a manipulation of the law of cosines, but it's for side angle side, but we're just going to say that's the formula for it instead of me showing the manipulation. Maybe I'll show the manipulation in class. All right, so this first one here, example 2, says find the angle theta between the pair of vectors, round to the nearest thousandth of a degree, so on 3 decimal places when I'm done. All right, so I need to use this formula right here. So what I'm going to do, it's v and w in this, is I'm going to find the dot product of v and w, so v dot w, and that is from a times a, 6 times -7, plus b times b, 8 times 9. So that is -42 plus 72, which is 30, and we get v dot w is 30. So that's the dot product. I got that right there, okay? And now I need the magnitude of u and the magnitude of v. So I'll do, the magnitude of v and the magnitude of w. All right, so remember the magnitude formula is the square root of a squared plus b squared. I think I made my square root way too big. Square root of 6 squared plus 8 squared. So that's the square root of 36 plus 64. Square root of 100, which is 10. All right, magnitude of w. 7, -7 and 9. So -7 squared plus 9 squared, square root of 49 plus 81, which is the square root of 130. Yeah. And that's a decimal. I'm just going to leave it until I get my final answer. All right, so now I have the 3 things in it. Now I have this, and I have this, and I have this. So now I'm going to write those in my equation. So I have cosine of theta is equal to the dot product, which is 30, divided by the 2 magnitudes multiplied. So 10 times root 30. Now I need to solve for theta, so I'm going to use cosine inverse. So cosine inverse of 30 over 10 times root 30. Now what's really important is, as I'm looking at this right now, is that that's 30 divided by, and then these 2 are multiplied. But these 2 have to be multiplied first. So when you're putting it in your calculator, if you don't do that, it'll divide these, then multiply by this, because it does your order of operations left to right. So please make sure that you put those extra set of parentheses in, and that'll give us theta. Let me show you how. Let me get my calculator up and running here. All right. Okay, calculator, calm down. All right, click there. Oh, so whenever I see this screen, I know that my calculator reset. So I'm in the wrong mode now, so I have to go back and change it to degree mode. Okay. All right, cosine inverse of 30 divided by, and then now I need an extra set of parentheses because I'm in the denominator, I need these to be multiplied. So 10 root 30. 130. Ooh, I knew that sounded weird when I said 30 because it was 130. So this was a 130. Let me go back in there and fix it. 130. And then get out of the square root, close the parentheses, hit enter. And I get 74 point in 3 decimal places for 1,000th, 745 degrees. And there is the angle in between those two vectors. Once again, it's using the law of cosines, but we broke it down already for you, so you don't have to like spread that all out. Okay, next one. Find the angle between the pair of vectors round to the nearest 1,000th of a degree. Again, so same idea. So once again, dot product first. So this is just repetitive to make sure that we're okay. So if you want to pause the video and try this on your own, I think it's a wonderful idea. All right, we have negative 2 times 12 plus 8 times negative 5. Once again, you can use a calculator for all this. You have a calculator right in front of you, but I'm practicing my mental math. Well, I messed up already. Negative 24 minus 40. So it's negative 64. The dot product is negative 64. All right, now I need the magnitude of t and the magnitude of u. All right, so square root of negative 2 squared plus 8 squared, square root of 4 plus 64, which is root 68. And that's a decimal, so I'm just going to leave it. And then for u, square root of 12 squared plus negative 5 squared. So like me looking at this, I go, oh, one side is 5, one side is 12. The hypotenuse, which is what you're finding, has to be 13. So I could jump to just writing 13 down. But just to prove it to you, 144 plus 25 is 169, which is 13. Okay? All right, so now I'm going to use my formula. Cosine of theta is equal to, I need the dot product, which is negative 64, over the two magnitudes multiplied. So root 68 times 13, which root 68 times 13, which in my calculator, I'm going to write 13 root 68, just so we're aware. All right, so theta equals cosine inverse of negative 64 over, and then once again in my calculator, I'm going to put 13 root 68 because it's the same thing, but make sure it's in parentheses. Reason why is because if I type the root 68 and I accidentally put the 13 under there, I'll take the square root of 6,813. All right, cosine inverse, negative 64 divided by parentheses, 13 times root 68, 13 root 68, close, oops, I'm underneath that radical still. So let me get out, close, enter, and I get theta is equal to, 3 decimal places, 126.656 degrees. So the angle in between those two vectors is a little bit over 126 degrees. All right, next one, which is the last one. 2 planes leave O'Hare Airport at the same time. The vector that plane A follows is A equals negative 200 plus 100j. The vector that plane B follows is B equals 500 plus 250j. Count the angle between the paths of the 2 planes round to the nearest 1,000th. I do have a picture here, which I do not need, but it does help with B. So I'm going to go ahead and wait to draw it until I do B. All right, so I need the dot product, A times B. Sorry, A dot B. So that's negative 200 times 50 plus 100 times 250. Big numbers here. All right, so I have negative 10 with 3 zeros, negative 10,000 plus 25 with 3 zeros. So that is 15,000. So A dot B is 15,000. And you can use a calculator, but I was just, doing some mental math. All right, magnitude of A, magnitude of B. All right, for A, I have negative 200 squared plus 100 squared, which is, getting my calculator. I'm not going to put the square root in because I'm going to leave the square root there just so that it can be exact as possible. So I'm going to do What's underneath? Negative 200 squared. Oops, that's 20. Oy. Second, insert another 0, please. All right, negative, it must faster just to clear it on this old, not old, but stupid. All right, plus, sorry about the droning on. 100 squared is 50,000. So square root of 50,000. And then this one is square root of, and that was 50 squared plus 250 squared. Then do the same thing. Keep the square root, not put it in my calculator. And I'm gonna do 50 squared plus 250 squared. I don't need parentheses in them as if there's no negative. All right, 65,000. Square root of 65,000. All right, so now I need to solve for theta. So I'm gonna do cosine of theta is equal to, should probably move this over a little bit since I'm getting close to running out of room there. There we go. All right, cosine of theta is equal to the dot product, 15,000, over the two magnitudes multiplied. I'm going to zoom in here so I can write them down. Square root of 50,000 times square root of 65,000. I could make that one radical if I wanted to, but I don't feel like it. All right, so this is in parentheses here, but this is also in parentheses here. So I have theta is equal to cosine inverse of that right there. So I'm going to save a little bit of time and hit copy and paste. All I got to do is get rid of that equal sign. Can I sneak in there and get rid of it? There we go. Okay, so now I'm ready to get that. Careful. Let's make sure I can type it right. Cosine inverse, 15,000. 15, 3 zeros. 1, 2, 3. Divided by parentheses. Square root of 5,000. 50,000. 50. 1, 2, 3. Get out of the square root. Square root of 65,000. 65. 1, 2, 3. Get out of the square root. Close the parentheses, hit enter. And I get theta is equal to 74.745. That seems so familiar. Did we already get that as an answer? Dang, we did. All the way up there. Weird. Okay, so that's theta. All right. So now it says, find how far apart the two planes are after 1 hour. Find how far apart the two planes are after 1 hour. So let's draw what this looks like so we can see what we're talking about here. So vector A is negative 200, 100. So that's negative 200 west and then 100 north. So let's say negative 200, 100. Let's say it looks like this. And that's that vector. Okay, that's A. And then B is over 50 up to 50. So this is like, wow, up here. Let's say. Like that. Okay. All right, so this was A and this was B right here. All right, so it says, how far are they apart after 1 hour? So this is this, let's say this is the start and this is the end. I want to know what this vector is right here. Okay, so let's use vectors to do this. I could say that I know what A is, it's square root of 5,000. I know what B is, it's the square root of 65,000. And I know what this angle is, it's this right here, and use law of sines. But we can use vectors instead. So if we say that's the start, this point right here, and that's the end, and I know that this is A plus B right here, how do I get that A plus B using A and B? Well, if I start here, I have to go in this direction. That is negative A. So I'm going to write that down, negative A. Then I would have to go this way, which is going plus B. So I can find that new vector by doing negative A plus B. So that's the opposite of A. So I want the opposite of this. So that's positive 200I minus 100J plus, and then B, which is this right here, 50I plus 250J. All right, so that vector is, combine like terms, 250I plus 150J. So that's what the vector is, and if I want to know the distance or how far they are, that's the length, which is the magnitude or the distance. So now I'm going to do the magnitude of that. I'm going to do square root of a squared. This is a, so 250 squared. Plus b squared. This is b, 150 squared. And this will give me my answer. So I'm going to put this in my calculator as soon as I'm done writing that down. Square root of, parentheses, 250, close it, square it. Once again, if I forget a parentheses on a positive number, not going to matter. Plus 150 squared. But I like to put them in so I don't forget them when I have negatives. And I get 291.547. 548, my bad. And this is a distance, how far apart they are. This is not an angle. And this does not have a unit on it. So, I hate to say I'm going to assume miles, but let's assume miles. And that's how